Parallel computers. We define a parallel computers as a system that make use of multiple processing elements to reduce application execution time or to increase system throughput. A parallel computers can also be defined as a machine to be programmed in parallel using some parallel languages, for instance. A processor core is an integrated circuit block implemented in an instruction set, producing a unit that is user programmable. A processor CPU is one or more cores implemented in one package from the user point perspective. A multi-core is a computer chip having two or more cores. You can also see it referred by CMP in the literature. And a node of a parallel computer is defined as a set of processing elements sharing a common address space. Typically, a node can be a multi-core. We distinguish two main kinds of parallel architecture, the one based on shared memory and the one based on distributed memory. In the case of shared memory, all the units, either vector or scalar, are seeing one global address space. In the case of distributed memory, you have multiple address spaces in the machine. And usually, what is really implemented is the hybrid. That is, there is multiple address space, and each node, you have a shared memory. So this is typical of a cluster of multi-cores. Historically, the Flynn's taxonomy was proposed to understand how the instruction flow is organized and how the processing of the data is organized in a parallel computer. So the first kind is actually not parallel, is single instruction, single data. In that case, each instruction processes one data at a time. This is, for instance, one core scalar ISA instruction set. Next kind is single instruction, multiple data. In this case, the instruction processes multiple data at a time in parallel. This is a case for vector architecture. For instance, the Cray YMP. GPUs are of this kind, and the Intel AVX ISA is also an instruction set of type single instruction, multiple data. The dominant form of organization is actually having a node, multiple nodes that can process multiple data and that are connected by a communication network. This is referred to by Flynn as multiple instruction, multiple data. Every cluster are of this kind. About the shared memory, we distinguish different cases. You have the uniform memory accesses. That means the CPU always sees the main memory with the same latency, same distance. So every core in here will actually see the memory for data from the same distance. The non-uniform memory accesses, when you start to connect multi-cores through, for instance, an Intel quick path technology, you will have different access time, latency to access the memory. So for instance, if this CPU is trying to access a memory data in here, memory block from here, it actually will take longer than if it is from here. So the access time for the memory depends on the address and is non-uniform. There is two ways to deal with caches in that case. The first way is to have incoherent caches. In that case, the software has to make sure that you have in the cache the up-to-date version. But usually, it is implemented by hardware, and their work makes sure that if a data is updated somewhere, it is taken into account in the other caches. So this is what's referred to as CC-NUMA, cache coherent non-uniform memory accesses. For the distributed architecture, to connect the node, we have two kinds of networks, the routing-based and the switch-based. The routing-based actually push the data from one node to the next one up to the destination. So typically, the data will do many hops. The advantage of this kind of networks is that there is a low latency connection between two adjacent nodes. The other kind of networks is a switching based. In this case, a data is sent through switches up to the destination. And in this example, the switch are used to create a fat tree network. So that means that when you go closer to the roots, you increase the bandwidth between two switches. The advantage of this node is that it doesn't have to route the data, so the latency is more or less very similar from one node to another one. So the questions for the course. What are the advantages and disadvantages of shared memory parallel computers? Same question for distributed memory computers. InfiniBand switches are very popular, so what kind of networks are implemented with these switches? What type of parallel computer is a node of the build XB510 from the build company? What type of parallel computer is the Oak Ridge Titan? What type of parallel computer is Cray 1? How many cores do have the biggest parallel computers? What type of parallelism are exploited in these machines? What has the speed of light to do with a parallel computer? Two references, the original paper from Flynn and another one on parallel computers. And if you want to know more about the QPI technology from Intel, you have a white paper here. That's it, so see you in class.